Hi everyone, this is Dr. Nak, and we are going to go over our practice exam number 3. This exam will cover from chapter 4.1 through 4.7 in OpenStack textbook. So let's just get started. Use the compound interest formula for the following problem. Dr. Nak wants to have $150,000 in 12 years to put a down payment on a house. To the nearest dollar, how much does she need to invest now in an account with 6.75 APR compounded monthly? Okay, so first of all, what you need to know is what each of the letters stands for in the compound interest formula. So first, let's just go with A of T. That's nothing but account value. And T is time in years. And P is the starting amount. I'm just going to put a dollar sign there. And R is the annual percentage rate. I'm just going to put percent rate. And N is the number of compounding per year. Okay, so I think we're good to go. So first of all, let's see. Right now, I want to have $150,000. So the account value, I want this to be $150,000. And T is a time in years, so which will be what, 12 years. And P is the starting amount. This is what I'm looking for in this problem. Now the little r is going to be what? 6.75%. Make sure to convert that into a decimal. So you'll be what? 0.0675. And what? The N should be 12 because I want to compound monthly. So I'm just going to write it as 12. Okay, so now what we're going to do is we're going to plug all these values into that formula. So 150,000 equal P, that's what we're looking for, 1 plus R over N, so it's going to be what, 0.0675 over N is 12, and then N times T, they're both 12, so I'm just going to put 12 times 12. Okay, so punch that in the calculator, and then, let me see. So I got this amount to be approximately 2.2428. Okay, so that means what? Let's solving for P. We're gonna have P is approximately equaling to 150,000. Whole thing divided by 2.2428. Type that in the calculator. To the nearest dollar, it looks like, what do we got? 66,880. So it looks like I need to put down $66,880. You gotta be kidding me. I don't have that much money. Maybe $6.88. I have it in my bank account maybe. But anyways, our answer is going to be 66,880. Okay. All right, so then let's go with number 2. Sketch the graph of f of x equal negative 2 to the x plus 3 and its asymptote. Label at least 3 points on the graph. Okay, so what I would do is let's just pick some values of x. And then let's take just 2 to the x first. And then we'll throw in the negative and then add 3 to it at the end. So the values that I'm going to pick is negative 2, negative 1, maybe 0, 1, 2. Okay, so let's compute 2 to the negative 2. 2 to the negative 2 is same thing as 1 over 2 squared, which is going to be 1/4. So this is going to be 1/4. 2 to the negative 1 is 1/2. 2 to the 0 is 1. 2 to the first is 2. 2 to the second is 4. Okay, so let me just erase this little scratch work down here. Okay, now if I want to toss that negative sign, all you have to do is throw the negative on each numbers. Okay, now what? You need to add 3 to this. So that means what? You're going to have to shift the graph of negative 2 to the x 3 units upward. Okay, so let me just write it as negative 2 to the x plus 3. So all you have to do is just add 3 to each of the value that you obtain from computing negative 2 to the x. So basically this is what? Negative 1/4 plus 3. Sorry, I'm writing this vertically now. Alright, so this is what? 11 over 4. So which is approximately what? 2.75. And what? So you're going to have to take negative 1/2 and then add 3. So this is going to be what? 2.5. Okay, so now we're going to have to take negative 1 plus 3. Now in this case, we're going to get 2. And then negative 2, oops, sorry. Let's just rewrite everything. Negative 2 plus 3, that's going to be 1. So this was 2. And negative 4 plus 3, which is going to be just negative 1. So the ordered pairs that we need to plot is, for the first one, you need to plot negative 2, 2.75. For this one, negative 1, 2.5. 0, 2. 1, 1. And then this one is what? 2, negative 1. Okay, so keep that in mind and let's just try to draw this out. Okay. Okay, so if you wanted to draw y equals negative 2 to the x, so that's nothing but y. So here you're going to have negative 2. So when it's negative 2, it's negative 1/4. And then when it's negative 1, it's negative 1/2. And when x is 0, y is negative 1. And what? When x is 1, it's negative 2. When x is 2, it's negative 4. So this graph right here, oh my gosh, pretend that is the most ugliest looking graph ever. Okay, let me try this again. It looks maybe worse. Okay, but anyways, so this is the graph of y equals negative 2 to the x. Okay, so to obtain our graph, you can just, shift every point 3 units upward. So when it's x equals negative 2, our y value is going to be 2.75. So maybe it's right here. When x is negative 1, it's going to be 2.5. Okay, and when x is 0, y is 2. And when x is 1, y is 1. And when x is 2, it's going to be negative 1. So you kind of get the idea of what the graph should look like. Okay, so this is the graph of f of x equals negative 2 to the x plus 3. Now, where is the asymptote? Okay, so let's take a look. The asymptote for y equals negative 2 to the x is what? Y equals 0, right? So do you notice that? This is going to be the asymptote for y equals negative 2 to the x. So since we're shifting everything above 3 units, the horizontal asymptote that you're going to get is y equals to 0 plus 3, which is y equals to 3. So that's going to be the asymptote for negative 2 to the x plus 3. So let me write that. So y equals to 3. Now the domain of the exponential function is all real numbers, so it's always going to be negative infinity to infinity. All right, now let's look at the range. Now when you read the graph, you're going to have to read the graph bottom upward. So the bottom portion of the red graph basically starts from negative infinity, and it's going to go all the way up. All the y value is going to go all the way up to y equals to 3, but it's never going to touch 3. So the range value, you can express your answer as negative infinity to 3. You will never touch 3, so you're going to have to leave it as open parentheses. Okay, let's go with number 3. Evaluate the following exponential or log expressions without using a calculator. Give exact answers. Okay, so let's go with part A. Log base 4 of 1 over cube root of 256. Okay, so what we're going to do is use this property, log base b of b to the x. This is going to give us x back. So since here the base is 4, what we need to do is try to rewrite 1 over cube root of 256 by using base 4. Okay, so let's go. So this is same thing as what? Log base 4 of 1 over the cube root. Now 256 is 4 to the 4th power. So I'm just rewriting in that way. Now, but the thing is, that's same thing as what? Log base 4 of 1 over 4 to the 4/3. I'm going to work this step by step. So that's same thing as what? Log base 4 of 4 to the negative 4/3. Okay, so now we can apply the property that I wrote in red. So this is just going to be negative 4/3. Oops, what did I just write? Okay, so the answer is going to be negative 4/3. All right, so now let's go with part B. Log of 0.001. Now, if you don't see the little base under the log, you're going to have to assume that that's log base 10. Okay, so let me just try to rewrite everything else. So this is the same thing as log base 10. Now, 0.001, that's same thing as what? 1 over 1,000. Okay, which is same thing as what? Log base 10 of 10 to the negative 3. So again, using the property in red above, the property that I wrote, this is going to be negative 3. So answer for B is going to be negative 3. All right, now let's go with part C. Log base 8 of square root of 2. Okay, so first let's set this value equaling to y. Okay, then by the definition, this means what? 8 to the y equals square root of 2. So what we're looking for is the value of y, because that's the value that we're looking for. Okay, so now we need to get that y value. So let's get to work. So let me see. 8 is same thing as what? 2 times 2 times 2. So 8 is same thing as 2 to the 3rd. And then here comes the y equals 2 to that. Square root of 2 is what? The power is 1/2. Okay, so that implies that what? We got 2 to the 3y equals 2 to the 1/2. Since base are the same, to solve for y, we just set the exponent equaling to each other. And what? Dividing by, or multiplying by 1/3 on both sides, it looks like y is going to be 1 over 6. Okay, so since, look at it, this is what we're looking for. Okay, so that means what? Our answer is going to be 1 over 6. All right, so now let's go with part D. 4 to the log base 4 of 97. Okay, easy peasy. Okay, but you're gonna have to know this formula. If you have b to the log base b of x, this is gonna give us x back. That's one of the properties. So here you're gonna have 4 to the log base 4 of 97. So the answer would be what? Just 97. Okay. Now let's go with E. ln of e to the negative 5. So another property that you need to know is this. ln of e to the x, you're just going to get x back. So basically ln and e, they're going to kill each other. Alright, so then with that said, our answer for this particular problem is just the exponent on e, which is negative 5. Okay, so now let's go get down to part F. Log base 3 of 9 to the 25th. So again, I want to equate the base. So since I'm given log base 3, let's try to write the argument 9 to the 25th power in terms of base 3. Okay, so what can we do here? I can rewrite this as log base 3 of, now 9 is what? 3 times 3? Okay, and then what? And then you still, so this is 9, and you still have the exponent of 25 left. Okay, so in this case, you need to multiply the exponents together. So here, what we're going to get is what? Log base 3 of 2 to the 50. Oh, sorry, 3. Goodness. Sorry about that. So log base 3 of 3 to the 50. So again, little base and big base matches up. So our answer is just going to be the exponent 50. Okay, so now let's go with the last one. Okay, I know it looks ugly, but you got this. So you got log of 10 to the 100. Okay, so again, since we don't see any little base attached on the log, so that means it's base 10. Okay, so let me just try to work this step by step by step. So let me try to rewrite this as, so first this is log base 10, log base 10 of 10 to the 100. Okay, so now let's look at this one. Notice that we have what? Log base b of b to the x. Now this is gonna give us just the x back. So in this case, what we're gonna get here is log base 10 of 100. Okay, now let's try to write 100 in base 10. So this is gonna be what? Log base 10 of 10 squared. Again, using that same property that we just used, so this is going to be just 2. So answer is 2. Okay, let me just box all the answers so you can see which one are the answers. There you have it. Okay, number 4, solve for x by converting the log equation to exponential form. So let's just apply the definition. So log base x of 9 equals 1/4. This means what? This is same thing as x to the 1/4 equals 9. Okay, so you got x to the 1/4 equals to 9. Okay, so now what we need to do is solve for x. So how do I solve for x? Well, maybe we should raise both sides to the power of 4. Okay, then what do we get here? This implies that we're gonna have x equals 9 to the 4th. Use your calculator, punch this in, and answer is what? Did you guys get 6561? I'm just gonna go with that, 6561. So I'm just going to box that for the answer. Okay, so number 5, expand the log as much as possible. Simplify your answer all the way. Okay, so when you do this, make sure that you take step by step by step. Don't skip any steps. Okay, so first what you need to know is this. This formula is what? Log of A over B. This is log of A minus log of B. And then log of A times B is log of A plus log of B. Okay, so I think we're ready to go with the, oh, one more thing is what? Log of B to the X. This is same thing as X log of B. Okay, so now I think we're ready. Okay, so first let's expand this by thinking that this is log base 6 of A over B, where A is cube root of x minus 1, B is 36y to the 4th. So here, my first step is going to be log base 6 of x minus 1 cube root, the same thing as the 1/3, and then minus log base 6 of 36y to the 4th. Okay, that's my first step. Now what we're going to do is let's just keep simplifying this. So this is same thing as, now look at it. For this portion here, you see we could use the third property here. Let's call this 1, 2, 3. So we can use property number 3. So here what we're going to get is 1/3 log base 6 of x minus 1. Okay. Now let's go with the second portion of it, log base 6 of 36y to the 4th. So what I'm going to do is, let's use property number 2, where A is 36, B is y to the 4th. But be careful, do you see that there's a minus sign on the front? Okay, so copy down the minus, and when you expand log base AB, you're going to have log of A plus log of B. So that means this negative has to distribute to log of B as well. So make sure to put bracket here. Okay, then you're going to have log base B of 36, and then plus log base 6 of y to the 4th. I'm running out of room. Okay, so now let's keep simplifying this. So this is going to be 1/3 log base 6 of x minus 1 minus log base 6. Now 36 is what? 6 squared. And then don't forget to distribute this minus sign. Make sure this is going to distribute to here and then also to here. Okay, so this is going to be minus. Now log base 6 of y to the 4th, we can apply property number 3. So here, what's going to happen is the exponent 4 goes on the front, and then we got log base 6 of y. Okay, so one more step. Now let's look at log base 6 of 6 to the 2nd power. Since the little base and big base matches up, what you're left with is just the exponent 2. So it looks like our answer is going to be, so I'm just going to write it directly below, 1/3 log base 6 of x minus 1 minus 2 minus 4 log base 6 of y. Okay, so I'm just going to box that for my final answer. Okay, so now let's move on to number 6, condense to a single log. Okay, so what we need to do is we pretty much work it backwards now. Alright, so staring at these 3 properties that I wrote on number 5, here what we're going to get is, the first one is what? Log base x of 1/4, and then minus log of x cubed plus 6 to the 2nd power just because I kept the negative as is. So the exponent is going to become positive 2. So let me just write like that. Okay, and then here you're going to have plus log of x minus 1 to the 5th. Okay, so now let's work it step by step. We're going to work from left to right. So let's combine these two by using property number 1. So let me just go over here. So this is same thing as what? Log of x to the 1/4 over x to the 3rd plus 6 squared. And then plus log of x minus 1 to the 5th. Okay, so now let's keep going. So now we could combine these two now by using property number 2. So let me just, I'm running out of room here. Okay, so this is same thing as what? Let me just write it over here. Log of x to the 1/4 is same thing as 4th root of x over x to the 3rd plus 6 squared. And then what? You're going to have to multiply the arguments together in this case. So then here you're going to have x minus 1 to the 5th. Okay, I think that's good enough. Okay, don't do anything to it. Just keep the answer the way it is. So the answer is log of 4th root of x minus 1 to the 5th, whole thing over x to the 3rd plus 6 squared. That's a big argument on a log. But anyway, so this is going to be the answer. Okay, so now let's go to number 7. Use the change of base formula to rewrite the expression log base 7 of 4.92 as a quotient of natural or common logarithm. Okay, so first, again, you need to memorize this formula. So key formula is the change of base formula, which is log base b of x. Okay, you can change this to any base that you want. Okay, so here I'm just going to write log base a of x and then log base a of b. Okay, so again, a can be any number. All right, so now let's go with this problem. So if I have log base 7 of 4.92, I like natural log the best. So I'm just going to apply the natural log, which is log base e. So here what we're going to get is what? ln of 4.92 over ln of 7. Okay, please note this. Okay, so note, I know it's so tempting to do it. Okay, ln of a over ln of b. This does not equal to ln of a over b. Be careful. Be careful right there. Okay, so what I mean is just leave the answer the way it is. So the answer is ln of 4.92 whole thing over ln of 7. Okay, so that's the answer. And here's number 7. Okay, number 8, solve each exponential equation, give the exact solution. If applicable, also give an approximate solution accurate to 4 decimal places. If there is no solution, write no solution. Alright, so let's go with part A. 5 to the 3x minus 6 equals 1 over 125. So notice that I can write 125 in terms of base 5. So here, what I would do is 5 to the 3x minus 6 equals 1 over 5 times 5 times 5, so 5 to the 3rd. Okay, so that's same thing as what? 5 to the 3x minus 6 equals 5 to the negative 3. Okay, so now what? We got the same base, and they're equal to each other. So how do we do this is to equate the exponents. So this implies that 3x minus 6 equals minus 3. And from here, all you have to do is solve for x. So plus 6 plus 6, 3x equals 3. Looks like x is going to be 1. Okay, so the solution set is just 1. And here we go. Okay, part B. Okay, 3 to the 2x plus 1 equals 7 to the x minus 4. So, alright, so in this case, there's no way that we're going to able to equate the big base. So, what I would do is apply the natural log on both sides. Okay, then what I'll do is apply the property of natural log, meaning exponent goes out in the front of ln. Okay, so keep in mind that ln of 3 and then ln of 7, they're just some kind of a numerical value. So treat them as a number. Okay, so next step, what I'll do is I'm going to distribute this constant into each term. Okay, so what do we get here? 2 ln of 3 times dx plus ln of 3 equals ln of 7 times dx minus 4 ln of 7. Okay, so now since we're solving for x, let's bring all the terms that has x attached on it on one side, all the constant on the other side. Okay, so to do that, I need to subtract ln of 7 times dx. Okay, then it looks like I'm dividing, huh? I am not dividing, I'm just subtracting it. Let me just erase this bar. Okay, so what are we gonna get? So here it looks like we're gonna have 2 ln of 3 x minus ln of 7 x. Now what I'm gonna do is I'm going to subtract the constant and combine all the constant terms together. Then here what we're gonna get is what? We already moved that, so you're gonna have negative 4 ln of 7 and minus ln of 3. On the right hand side of the equal sign, you could type it in a calculator if you want, but that's just some kind of a decimal value. Okay, so since we're solving for x, factor the x out from here and from here. Alright, then what are we going to get here? 2 ln of 3 minus ln of 7 times dx. All I did was I factor out dx equals negative 4 ln of 7 minus ln of 3. Okay, so now what? All you have to do is divide it by 2 ln of 3 minus ln of 7. Divide the same thing over here. 2 ln of 3 minus ln of 7. Okay, so it looks like what we're going to get is x equals negative 4 ln of 7 minus ln of 3, whole thing over 2 ln of 3 minus ln of 7. Yes, you can simplify this a little bit more, but don't do it. Just leave that as your answer. Okay, so I'm going to write it as solution set is negative 4 ln of 7 minus ln of 3, whole thing over 2 ln of 3 minus ln of 7. Okay, just box that for the answer, and here you have it. Okay, the next one, part C. Alright, e to the 2x minus 5e to the x minus 14 equals to 0. Okay, so let me just do it this way. I'm going to say let y equals e to the x. Then do you see that I can rewrite the given equation as what? Y squared minus 5y minus 14 equals to 0. All right, now is this factorable? I think so. Now let's factor. So here you're going to have y and a y. One sign better be plus and minus like this. How about 2 and a 7? Would that work? Y squared plus 2y minus 7y will give us negative 5y, and then minus 2 times 7 is negative 14. Alright, so I think this is good. Okay, so that means what? Either y plus 2 is 0 or y minus 7 equals to 0. So this means what? Y equals negative 2 or y equals to 7. But our y was e to the x. So make sure to convert that back in terms of e to the x. So we got e to the x equals negative 2 or e to the x equals to 7. Since we're solving for x, on the next step what we need to do is apply the natural log on both sides. So here what we're going to get is what? ln, why did I put that in blue? Okay, sorry. So here you're going to have ln of e to the x equals ln of negative 2, comma, ln of e to the x equals ln of 7. So it looks like here you're going to have x equals ln of negative 2. Oh no, let's take a look at that. Could that happen? I don't think so, because remember the domain, let me just write it over here, the domain of natural log or any kind of log. So let me just go with domain of ln of x is nothing but set of all x such that x better be strictly greater than 0, meaning log of a negative number or log of 0 is undefined. Okay, so in this case, do you see that I need to throw this away? All right, now let's go with the right hand side. Then here you're going to have x equals ln of 7. Since the argument is positive, we can keep that one for the answer. So therefore, the solution set is going to be ln of 7. Okay. All right, so now let's get to part D. Negative 4 plus e to the 6x plus 5 equals to 25. Okay, so before anything, isolate the exponential function. So that means what? You need to add 4 to both sides. That's your first step. Then here you're going to have e to the 6x plus 5 equals 29. Okay, so now I need to solve for x. So what we need to do is attack both sides by natural log. So here you're going to have ln of e to the 6x plus 5 equals ln of 29. Again, ln of 29 is some decimal value. So the next step, we're going to have 6x plus 5 equals ln of 29. Right, so then what? 6x is going to equal to ln of 29 minus 5. Dividing by 6, it looks like we're going to have x equals ln of 29 minus 5, whole entire thing over 6. Okay, so I'm just going to write that as a solution. And there you go. Okay, number 9, solve each log equation and give exact solutions. If there is no solution, write no solution. Okay, so let's go with part A. So first thing what I would do is combine the natural logs together. So if I combine this, we're going to have what? ln of A minus ln of B is ln of A over B. Okay, so this is going to be 2. Okay, so now I need to get rid of the ln. So what we need to do is what? Compose both sides by e to the x, or what I call it, just e it. Meaning raise everything over e. So if I do that, we're going to have what? If I write every step out, e to the ln of 3x minus 5 over 5x equals e squared. Okay, so then what's going to happen is you're going to have 3x minus 5 over 5x equals e squared. E squared is a numerical value, so multiply both sides by 5x, so then we're going to have 3x minus 5 equals 5e squared times dx. Okay, so since we're solving for x, what I'm going to do is I'm going to subtract 5e squared x from both sides and then add 5 to the other side. Okay, so if I do that, then let me just write every step out. And I'm going to add 5. Okay, then here it looks like what we're going to get is 3x minus 5e squared times dx equals to 5. Okay, so now what we're going to do is factor out the x. So here you're going to have 3 minus 5e squared times x equals to 5. Dividing by what's in the parentheses, so it looks like our x is 5 over 3 minus 5e squared. Alright, so let me just box this, but when you're solving the log equations, you're going to have to be careful because the argument of the log has to be strictly greater than 0. Okay, so what we need to do is when I plug my proposed solution for x into, let me just write this out. If I plug this in to here and then also to here, do I get a positive quantity? Okay, so that's what you need to check. All right, so if I check that, let me just go over here. So 3x minus 5. Okay, you can use your calculator, of course. So here you're going to have 3 times the x. X is what? 5 over 3 minus 5e squared, and then minus the 5. Okay, so if I did this correctly, I got this number to be approximately negative 5.4. Okay, so right there, you can tell that you cannot have a natural log of a negative. So this is not going to be a solution. Our proposed x is not going to be a solution. But, you know, for kicks, if you want to check the other one, 5 times dx, so this is what? 5 times 5 over 3 minus 5e squared. So here, what I got was, this is what? Negative 0.73. The fact is that it's going to be negative, so it's not good. So guess what? In this case, our proposed x cannot be a solution. How do I write this out here? So here, let me just box it like this. These cannot be, so these are negative, but you cannot have ln of a negative number. Okay, so our solution is going to be no solution. So notation for that is curly bracket with nothing in it, or you can just simply say no solution. Okay, there you go. All right, so the next one, part B, log of x plus 4 minus log of 5x plus 1 equals log of 2. Okay, so first, again, I'm going to combine the logs together. Then here what we're going to get is log of x plus 4 over 5x plus 1 equals log of 2. Now log of 2 is just a numerical value. Now what? How do I get rid of the log? So log is same thing as log base 10. So what we need to do is we're going to have to raise both sides by 10 or compose by 10 to the x. Alright, so if I go 10 to the log of x plus 4 over 5x plus 1 is 10 to the log of 2. Okay, so then what we're going to get here is what then? Let me see. let me see, let me just write little 10 so that you can see what I'm doing. So here what we're going to get is x plus 4 over 5x plus 1 equals to 2. Okay, so let's multiply both sides by 5x plus 1. So here what we're gonna get is, let me just write this out. So this implies that we're gonna have x plus 4 equals 2 times 5x plus 1. Okay, so now what I'm gonna do is distribute the 2 to each term. So x plus 4 equals 10x plus 2. Okay, so let me see, solving for x, I'll just go minus x, and then minus 2, just like that. So then what do we get here? We get 2 equals 9x, that's it. So it looks like our x is going to be, what is that, 2 over 9? Okay, so let's just box that. This is our proposed solution. And let's plug this into the argument of the log to make sure that it's going to give us a positive value. Okay, so if I plug this value into here and then also to here, is it going to give me a positive value? Well, of course. You don't need to check here because look, if you have 2 over 9 plus 4, that's going to give us a positive value. 5 times 2 over 9, that's a positive value. And then if you add 1 to it, it's still going to be positive. So it looks like our solution set is going to be 2 over 9. Okay, our last problem. An unknown radioactive element decays into non-radioactive substances. In 20 days, the radioactivity of a sample decreases by 13%. Part A. Find the exponential decay model representing the amount for the decay after t days. Alright, so first what you need to know is this formula. So please memorize this. Where can I write it? I'll just write it right here. A of t equals a sub 0 e to the kt. Memorize this formula. This is the key formula to solve these problems. Okay, so you're like, what does each letter stand for? So here, a to the t is remaining radioactive substance. And then a sub 0 is the initial population. And then K is the decay rate. Now, notice that since it's decaying, K better be negative in this case. Okay, and then T is number of days. Okay, so I think we're good to go. Now, what's tricky about this problem is that there is no starting amount, meaning starting amount is not given to you. So that just means that this problem does not depending on a sub 0. So you can basically use any value for a sub 0. Do not complicate your life. What is the cutest little number that you should let a sub 0 to be? 1. That's the easiest way out. Okay, so first I'm going to take a sub 0 to be 1. Goodness. That was the ugliest writing. Take a sub 0 to be 1. Okay, now let's read this through. It says what? The sample decreases by 13%. Okay, so let me just write it out. Okay, so sample decreases by 13%. That means what? How much are left over? Okay, how much is left over is what then? 87%? So that means 87% is left. Okay, so guess what? Remaining radioactive substance is denoted by A of T. So this is 87% is going to become our A of T. All right, so here what we're going to get is A of T is going to be always in decimals. If you have a percent, always convert that into a decimal. 0.87. So we got A of T. We have A sub 0. Now let's go with T. So T is the number of days that we're given. So what are we interested in? In 20 days. So here our T is going to be 20. All right, so I think we're ready. Let's plug all these values into the equation. A of T equals A sub 0 e to the kt. Here it looks like we're going to have what? 0.87 equals A is 1, and then e to the kt, so t is 20, so you're going to have 20k. All right, so that implies that, let me see, let me just write it, 0.87 equals e to the 20k. Now if I want to solve for k, what we need to do is what? Attack both sides by ln, or compose both sides with natural log of x. So that implies that natural log of 0.87 equals natural log of e to the 20k, which is just going to give us 20k back. All right, now let's go with k. Our k is going to be, what is that? Natural log of 0.87 whole thing over 20. Now let's type that in the calculator, and k better be negative because we're talking about the decay model here. Okay, so if you get a positive number, you did something wrong. All right, so punched it in the calculator, and I got, this is approximately equaling to negative 0.00006963. That's pretty much what I got for the value of k. So I'm just gonna box this. So this is going to be our k. All right, now I think we are ready to write the model for this. So exponential decay model looks like it's gonna be A of t equals A sub 0, we're taking it to be 1. So here what you're gonna get is e to the kt. Our k is negative 0.006963 times the t. Okay, so it looks like that's gonna be our model. Just box this. All right. Okay, so let's go with part B. What is the half-life of the sample? Now, half-life means half of the time for the radioactive element to become non-radioactive element. Half of the time of that. All right, now round your answer. Oh, so round the number of days to 1 decimal place. Okay, so we're taking A sub 0 to be 1. Okay, and then we got A of t, it's a half-life, so you're going to have 1/2. And the question here is, what is the value of t? That's what the question's asking. Now, there is a shortcut to this. All right, so the shortcut, everyone likes the shortcut, but I'll do this formally as well. Now, if you're given the value of k, then you can apply this formula. Your t is always going to be negative ln of 2 whole thing over k. All right, so you can use this if you want to. So what are we going to get here then? So our t is going to be negative ln of 2. Now our k is what? Negative 0.006963. So typed it in the calculator, and you should get t's approximately equaling to 99.54, but to the one decimal place will be 99.5. Okay, so that's me using the shortcut. Feel free to use it, but if I have to do this formally, let's just go back to what we were doing before. Now here what we're gonna get is what? Plug this into the formula. A of t equals a sub 0 e to the kt. But we already have the model above, so here let me just rewrite this guy as, let me just erase this portion too, sorry, because we're taking a sub 0 to be 1, so you're gonna have e to the negative 0.006963 times the t, but our a sub t is 1/2. So here what I'm going to do is I'm going to erase this and just insert 1/2. Alright, so now what? If I want to solve for t, I need to kill that ln. So I'm going to attack both sides by ln, or more nicely said, let's compose both sides with a natural log. Alright, ready? So you're going to have ln of 0.5, 1/2, same thing. It's going to equal to ln of e to that decimal value. So ln and e, their inverses of each other, so what you're left with is negative 0.006963 and a t. Alright, now if I want to solve for t, you need to divide both sides by that decimal value. So t is going to be ln of 1/2, 0.5, same thing, whole thing over negative 0.006963. Alright, so type this in the calculator. Now notice that ln of 0.5 is same thing as ln of 1/2, which is same thing as negative ln of 2. Okay, so if you type this in, you're gonna have 99.5. Just like what we got by using our shortcut method. Alright, so the half-life is going to be 99.5 days. Alright, so let me box that. Okay, so this means what? Half of the time for the radioactive element to become non-radioactive element is going to take 99.5 days. Alright, so now let's go with part C. When will a sample of 80 milligram decay to 20 milligram? Round the number of days to one decimal place. Alright, so here, can you tell what you're given? When will a sample of 80 milligram decay? So here, what you're giving is a sub 0. The initial value is going to be 80 milligram. And then what we're looking for is, okay, so when a of t is going to be 20, now what is that value of t? When a of t is 20, a sub 0 is 80, what is the value of t? So that's what the problem boils down to. Okay, so what we're going to do is we're going to use that model that we got in part A. So what do we got? Our model looks like a of t equals e to the negative 0.006963 and a t. Alright, so here our a of t is 20. Oh, sorry, I forgot a sub 0. In this case, we're given a sub 0. So here you're going to have 80 times e to the negative 0.00696 3t. Okay. Now, before I'm going to apply the natural log, what I need to do is I need to divide both sides by 80. Don't forget to do that. Okay, so it looks like we're going to have 2 over 8, which is what? 1/4 equals e to the negative 0.006963 and a t. Now, applying the natural log on both sides, we're going to have ln of 1/4, and we're going to have ln of e to that exponent, so you're going to have 0.006963 and a t. Okay, solving for t, let's go. So t is going to be what? ln of 1/4 whole thing over negative 0.006963. Alright, so type this in the calculator. Okay, if I typed it in correctly, I got this to be approximately equaling to 199.09, so it's going to be 199.1. So how many days? How many days it's going to take the 80 milligram to 20 milligram? It's going to be about 199.1 days. Make sure that this is going to be bigger than Half-Life. Anyways, here's the answer. Okay, so I think we're done here. If you have any questions, please let me know. And then if I made a mistake, please let me know. Good luck. You got this.